Coming up on the FRC Open Alliance Show, 4639, the RoboSpartans from Texas are coming in, and they have some really great CAD and prototypes that they've been working on that they're going to be showcasing as well too. Really like what they're looking at doing for the deep climb, so make sure you pay attention to that and what they're looking at doing. But we'll be talking about more of that, including what they're doing for an algae intake as well, including scoring up high for that and taking it off the reef. And kind of this dual algae coral intake and score that we've seen as well too. So a lot of great stuff. We'll be diving more into their CAD and some of their progress and what they plan on doing, of course, getting ready for a week 1 event and what that progress looks like for their team. So make sure you follow their build log, learn more about them here, coming up here on the FRC Open Alliance Show. This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions. Go ad-free and access our videos earlier when you support fun with a membership through YouTube Join. For $4.99 a month USD, you can now watch most of our YouTube videos ad-free and gain early access to scheduled content with other options also available. Click the join button below to get started. Let's welcome on to the Open Alliance Show, 4639 at RoboSpartans. They're competing weeks 1 and 3, so lots to go through as week 1's coming up super quick in this season as well, and we can't wait to see what their progress is so far. So, hey guys, thanks so much for joining us. Why don't you introduce yourselves, and then we're going to be jumping in right into what you're doing for your algae intake.
Yes, sir. My name is Parham. I'm the president of Team 4639.
And I'm Jasper. I'm the build director.
All right, so I wanted to first go ahead and get started with our algae intakes. So we have one main prototype which we've been working on this build season. So this prototype which we've been working on, it was inspired by the Team Screen one. And so this was our first design. This was our first iteration. I think most of it was based mostly entirely off of their preliminary CAD for their system, and so we incorporated a lot of the same elements as they did. One of the issues that we ran into, however, was our pivot. So we wanted to clean up the packaging and just make it a little smaller. So we tried running only one sprocket, and we found issues where the two plates just wouldn't really hook up to each other correctly. And so we tried adding this Lexan bar, essentially, to stiffen it all up and just make it slightly more stiff and just try to keep it in the same line. However, we still found that was an issue. Yeah, so in order to fix that issue, what we did instead was on the main design, instead of this being a dead axle pivot, we turned this into a live axle pivot. However, in order to make sure that these pulleys are going to be running properly, we are using these AndyMark 42 tooth pulleys, and those have bearing holes which you can put bearings inside. So essentially we're running a live axle pivot with a dead axle bearing. So that allows us to get the proper stability during the pivots we need. So I want to give you guys a demonstration of how the intake works. So essentially we have these two gears hooked up to this belt, and that allows us to reverse the direction of the wheels. So here, let me. So as you can see, it's really quick, and these rollers that we have up here, they're really good for grip. So we made these in-house, and the rollers themselves are just AndyMark. They're the VersaHub rollers from Vex, and yeah, so we originally tested with 2-inch flex wheels, and we saw that the 2-inch flex wheels, it doesn't really work as well because it's compression stacked on compression. So we decided to go with a more solid design. So we wanted to go with these solid rollers instead with foam on top of it. So we saw that worked best for us. And then once we go up to the processor, all we do is just stand up right next to it and then just get it out like that. So, yeah.
In one of your videos that you had, I saw that, actually, the one we're going to show on screen, that your intake was kind of canted back almost a little bit, that sort of thing. Is that still the way you're looking at scoring, or will that be more vertical like you just showed?
It will be more vertical. So we tested it vertical to make sure it would work, but in that video, we were just running everything off of Rev Client, and so it was kind of hard to keep everything up. And that was also one of the issues we ran into, because of the issue which we were talking about, that it was kind of, the pivot itself was unstable. It was difficult to make sure that it would stay up vertically when the motor was just on brake mode. So
that was the issue we had to fix with the turning the pivot from a dead axle to a live axle to make sure that the torque is being applied on both sides evenly. So yeah.
I also want to ask you real quick about your compression as well too. How'd you figure out how much compression you wanted to put on the Algae? Because I mean, we've seen teams like completely squish it before. We've seen teams do just a little bit, and you're kind of in between. Like, how did you figure out what worked out best for you?
Yeah, so it was kind of a battle between packaging and also kind of what helps us get have like the touch it, own it principle. So from our initial testing, just like the first couple of days of build season, we just made 2 wood boards with a bunch of bearing size holes so that we could just like bring a shaft down and down to see, what was the optimal compression for the Algae so that you could get it in really the quickest. And we saw that the best compression, which we got in terms of speed and also being able to have the most grip on it, was roughly about, I would say 3.5 to 4 inches of compression. So we kind of stuck to that. And yeah, so that just helps us make sure that whenever we have contact with the Algae, we're able to have possession of it in the robot. So the next thing we wanted to kind of talk about was our 2 different scoring mechanisms. So
first off, our main just design. We saw the WCP competitive concept, and we thought that sort of scoring mechanism was pretty neat. So this was the remnants of our prototype of it. So you can see we cut the plates for the algae and the coral. So one of the main things to watch out for in this case is that this roller needs to be just locked in place. It cannot spin at all. And we found that if it spun even a little bit, there would be issues with holding it in place and just keeping it in our robot. And so,
yeah, so we kind of iterated the design a little bit. So we went into this second design, and this is a little bit more towards our final design. So the concept is the same. You have these 2 wheels which help intake the coral, and you have this gap at the bottom which helps you intake the algae. However, the main difference is packaging. This is slightly larger. However, we saw that this was able to just have like better holding capabilities in terms of the algae specifically. So let me give a demonstration on how this works. So here, Jasper, if you hold this. Essentially how it works is, so here's our pivot point over here. And from the perspective of the robot, if this is you see the elevators here, how it's going to be is that this is the front side of the elevator, and this is the front side of the robot, and this is the back side of the robot. So the coral goes in through here, and then through a funnel system, and then once it's here, the entire subsystem pivots, and then we raise our elevator up, and then we can just shoot it out like that. So this really helps us because one of the things we saw during our strategy during the initial phases of build season was, since this game is so focused on timing with everything and making sure that you can get everything as fast as possible, we really made sure that we could have a robot which could pick up from one side and score from the other. So we had several ideas for this. We initially thought we should make a coral ground intake and have a handoff system for our scoring subsystem. However, we saw that integrating that, especially with the new weight limits, that would be very difficult. So once the WCP competitive concept came out, we kind of shifted more towards that idea of having a funnel which would allow you to go directly inside the scoring. And that also helps us with autonomous because that makes on-time pass required to be less precise. So that's one of the other things we wanted to emphasize on. So, and then this is really simple as well because it helps us take algae off of the reef and score it directly either into the processor or in the barge. So let me give a demonstration on how that works. Essentially, you have this wheel which spins, and then you would go up to the algae like so. And then,
Yep. Okay. So
yeah.
essentially, what is going to happen is just get stuck in there. We're still playing around with a variety of compressions to see if we can better our packaging, but this looks mostly fine. We're still going to do a couple tests on the compression. As you can see, the coral's compressed quite a lot, and yeah, that's the majority of that.
Yeah. So then we can spit it out either into the processor or the barge like that. So
are you looking at having any sort of then like handoff that goes in between like that ground intake into there so you can score up high as well, or is it going to be, hey, we're only going to pull from the reef in order to do that?
yeah, so for the barge, we're planning on only pulling from the reef to do that. We're not planning on doing anything with a handoff system from the ground intake to the scoring subsystem. So yeah, the ground intake is mainly for things we want to score into the processor, and then we're just going to pull off the reef directly to score into the barge.
Our main concern with such packaging was if you look at the WCP competitive concept, one of their things that's like really tight at the front of the robot is that their scoring mechanism is only able to, it only pivots out. So all the packaging at the front of the robot is really tight, and we don't think that it's feasible really to pass it off or even worth it, because there's only going to be 3 algae on the ground at the start of a match, realistically, and the rest of it we can just pull off the reef as we de-algify it.
Yeah, there's a lot of trade-off, right? If you're going to do something like that, you're committing a lot of resources to add what might not be very much more points in that standpoint. So yeah, I like your analysis of that for sure too. So yeah, what else do you guys want to showcase?
Kind of last prototype we wanted to showcase was our deep climb. So this was one of our prototypes that we're still working on and making it kind of more efficient. So here, essentially how it works is, this is kind of a version of the Panther Bots climb. So how it works is this plate latches onto the kind of the bottom of the anchor. So how it works is that once this part latches on kind of between that bottom of the anchor and the little circular part of the pipe, this gearbox pivots. It's on an 80-to-1 reduction, so I can't pivot it with my hand, but this gearbox pivots, and then once it pivots, it's able to kind of just make the robot lift up, and then using the friction from that plate and this plate. And then one of the cool things about this is we're using a ratcheting gearbox, and then we're using the AnyMark servo to allow us to turn on the ratchet and turn off the ratchet. So that allows us that if we mess up the climb, we can just go back at it with kind of making the servo open up, and that allows us to essentially kind of retry the climb. So yeah, this was one of the prototypes we've been working on. So the thing we're still trying to iterate is, one of the issues we had was, as you guys can see in the video, it's a little bit difficult to line up the climb. So in order to fix that, we're trying to make a design which kind of wraps around the cage, not entirely, but just enough so that the cage doesn't rattle around so much side to side when we're trying to climb. So the main purpose of this is so that, come the end game, we don't have to spend 30 seconds climbing. We can just do a quick 10-second climb or even shorter. So that's really the main trade-offs we're trying to go for. We're trying to figure out a way to make our climb quicker and without taking up too much space in the robot. So yeah, this is our climber prototype.
One of the things I'm looking forward to diving more into once we hop into your CAD in just a little bit too is like, how is that all packaged together, right? Because you have to try to figure out how do you not get contact and that sort of thing. So once we get to your CAD, I'd love to jump more into that too.
Yes, of course. Actually, I think now's a great time to talk about the CAD. So
sure.
Here, let me get the phone. Yeah. Okay, so as you mentioned, packaging, that was definitely one of the biggest struggles we had this year. So everything's super tightly packed. So as you guys can see, our algae intake is right on the side of the robot here, and it's super close to the elevator. One of the concerns we had was, is this enough space to make sure that the algae stays in place? But we saw that the algae is able to be like held and basically have full ownership of it with very little surface area contact. So that was, we decided to just fit it on the side of the robot over here so that we can just save space on the back for the climber. So here's our elevator. Our elevator is a 2-stage cascade. Initially in our build blog, we had mentioned we were going to make it continuous. However, we saw several trade-offs. So the thing with continuous is that the rigging is simpler. However, it's also slower. And for this year's game, we saw that we wanted to emphasize on speed. And since Cascade is quicker, we decided to switch our design to a Cascade. So
This is kind of similar to the WCP design-ish, but essentially their design has a gearbox up front over here. However, we're running our chains on the side of the elevator like this. So to continue about the climber mainly, our plan is put the climber in the back. And the reason why the elevator and everything is so far forward is from our testing with the climber, we saw that the chain and the anchor kind of protrudes a good 5 to 7 inches minimum inside the robot. So we've put our elevator and everything, all the other components here, like a decent 16 inches forward at least. So that's just to help us give us safety to make sure that none of the chain components hit anything in the robot so we don't get those major foul points. Now, regarding the pivots, another issue that we saw is that in order to make sure that our climber works perfectly fine, we need to make sure that our pivot, or there's nothing above the climber. So we realized that if we want to pivot, that means something's going to obviously be above the climber. So in order to fix this, what we're working on currently is a pivoting funnel. Sorry, I said pivot. We need to make a pivoting funnel for the funnel which feeds the coral into the scoring subsystem. So how that's going to work essentially is we're going to have our climber here, and then the shaft over there with two 2x1s raised up over there, and then we're going to have our funnel on the same pivot point as the climber. However, one of them is going to be dead axle, one of them is going to be live axle, so that we can control them independently. And then we're going to use a programming sequence in order to make sure that once the climber climbs, the pivot is able to fold down just in time and fold down whenever it needs to in order to make sure that it doesn't interfere with anything regarding the climber, and make sure it doesn't hit any of the chain or anchor or anything like that. So yeah, that was kind of the main design challenges we had. Other than that, our design has been coming along pretty smoothly. The main things that we need to work on currently is just the climber and the funnel. And then once those are complete, our CAD should be fully finished.
And you are competing weeks 1 and week 3, right? So time is, it comes up really quick, I know, for something like this. So what, for your team, like what's kind of your next big objective in order to start manufacturing? Are you looking at completing all the CAD? Are some of the stuff you have behind you, will that be used on the robot, or is there different manufacturing processes that need to happen first?
So currently, the students in the Bay are working on 2 of our main subsystems. Right now, they're manufacturing the main elevator, and they're also manufacturing the main algae ground intake. So essentially how we do it is once we finalize these prototypes, we make our prototypes in such a way that it's going to look almost one-to-one to the real robot design. So that makes it so that once we make the real robot design, we know we're not going to run into issues which we couldn't have seen in the prototype. So pretty much we just get all the machining done in a day or 2, and then work on assembling super quickly, and we just mount everything on the robot. So what our timeline is looking like is by tomorrow, so currently programming has had the drivetrain for about the last 2 to 3 weeks, just working on autonomous paths. And so tomorrow and Friday, we're going to take the drivetrain, redo the wiring so that the elevator can fit on, and then we're just going to mount the elevator and the ground algae intake and also the scoring subsystems. So we're going to all 3 of those mounted and assembled by Friday, if not Saturday. So yeah, so we're just pretty much going on a pretty fast pace. So we spend a lot of time on prototyping, make sure everything works fine. Then once we know everything's going to work, we're just going to quickly machine everything, put it all on the robot. So yeah, that's pretty much what our timeline is looking like. And then yeah, our plan is get the robot done and assembled by the end of next week. And from our timeline which we made, the goal is to be able to complete 1 full cycle with the robot by the end of next week. So yeah, we did a week 1 last year, and that was pretty much the same timeline we went about as well, and we saw that's kind of what worked best for us.
Well, you can continue to follow the RoboSpartans, of course, on their Chief Delphi build logs, and make sure you're doing that, including some of that pathing they mentioned. They have some stuff on there for that as well, too. So, RoboSpartans, thank you so much for taking the time to tell us more about your progress. It's been great to see, especially following along on your Chief Delphi build log. So make sure you continue to do that. And wish you best of luck with weeks 1 and 3. Can't wait to see how you do. Thanks a lot.
Thank you.
Thank you.
AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions.